CP Bank. A student sits atop a platform a distance h above the ground. He throws a large firecracker horizontally with a speed v. However, a wind blowing parallel to the ground gives the firecracker a constant horizontal acceleration with magnitude a. As a result, the firecracker reaches the ground directly below the student. Determine the height h in terms of v, a, and g. Ignore the effect of air resistance on the vertical motion. So here is our student. He's throwing a firecracker with an initial speed v horizontally, as you can see here. Because of the effect of the wind, the firecracker makes it to the basically ground directly below the student at a distance h from the level of the student. Okay, so we have this wind blowing and giving it an acceleration a that causes this motion. So if we look at the x component of the velocity as a function of time, initially we have v, but gravitational acceleration points downward, therefore it has no effect on the x component. However, the wind blowing gives it an acceleration in minus I hat direction, so that it's going to end up below the student. And the y component of the velocity as a function of time is basically minus gt, because it has no initial y component. So the distance we travel on the y-axis, delta y, is the integral from 0 to time of flight, tf, vy of t dt, which is the integral from 0 to time of flight minus gt dt. So that is minus 1 over 2 g time of flight squared. And finally we reach 0. Initially we were at h, so it is minus h. Therefore, we find that the time of flight is going to be square root 2h over g. So it's going to be 2h over g square root. Okay. Now, at the same time, the distance traveled on the x-axis, rather the displacement on the x-axis, delta x, is the integral from 0 to time of flight, vx of t dt, and that is going to be integral from 0 to time of flight, v minus at dt. So the final position on the x-axis is 0. Therefore, v times time of flight minus 1 over 2 a t time of flight squared, that is this integral basically evaluated between time of flight and 0, because it's 0 at 0, we obtain this. And this has to be equal to 0 because it ends up right below the student. So we can see that one of the time of flights cancel. So v minus 1 over 2 a time of flight must be equal to 0. And time of flight, on the other hand, we found to be square root 2h over g. So this is going to be v minus 1 over 2 a square root 2h divided by g, and that's equal to 0. So we find that v is equal to 1 over 2 a 2h over g square root, and this gives us 2v over a is equal to square root 2h over g, Okay, and therefore we can solve for h from here. This is going to become 4v square over a square. If I take the square of both sides, 4v square over a square equals 2h over g, and you can see that this 2 makes this 4 2, and therefore I obtain the height h to be 2gv square 2gv square over a square. Okay, so that's basically what I was after. Determine h in terms of VA and G, and this is in terms of VA and G. Now, however, I am quite curious about the dimensions of this quantity. Just to make sure that I did the right thing, I want to check the dimensions of the left hand side and right hand side and see if they are equal. This is a good exercise when you have spare time, extra time in an exam, for example. You can check the dimensions of your answer and see if the physical dimensions make sense. So let's check the dimensions as an extra exercise here. The dimension of h obviously is length because it's a distance. The dimension of gravitational acceleration is, it's an acceleration, so it is L divided by t square. The unit is meters per second square, length divided by time square, which is also equal to the dimension of acceleration. The dimension of velocity, v, or speed, is the distance traveled per unit time, so it is L divided by t. So if I look at dimension of gv square over a square, gv square over a square, this is basically dimension of g, which is L divided by t square, dimension of v square, which is L square divided by t square, and then I have dimension of 1 over a square. A has the dimension L over t square, so 1 over a will have t square over L, so we will have t square over L square. And what is the end result? I have t to the fourth power on top, t to the fourth power on the bottom, so they cancel. I have L squares canceling, and I'm left with only a single L here. Therefore, I realize that the dimension of h that I have obtained, which is in terms of g, v, and a, matches with the dimension of my answer. So h has the dimension of length, and gv square over a square also has the same physical dimension. Okay, so let's summarize. We have a student who is throwing a firecracker horizontally with an initial speed v. So horizontally it's in v I hat direction. There is a wind blowing here. So there is a wind blowing, which gives an acceleration that causes the acceleration acts in such a way that causes the firecracker to end up right below the student, and the wind is blowing parallel to the ground. So let me make sure that this is indicated here. The wind is blowing parallel to the ground. So this is the wind. So the wind gives it an acceleration a, so that it ends up right below the student on the ground level. So I want to know the height of the platform in terms of the acceleration a, g, and the initial speed v. So I look at the x component of velocity, which is v minus at because it has an acceleration to the left hand side, and the y component of velocity is minus gt because I have gravitational acceleration. The displacement on the y-axis is minus h, the displacement on the x-axis is 0. The displacement on the y-axis is integral 0 to time of flight vy of t dt. So from this I obtain time of flight as square root 2h over g. The displacement on the x-axis is integral of v minus at dt from 0 to time of flight, which is v times time of flight minus 1 over 2 a time of flight squared. And since I know time of flight is square root 2h over g, I can substitute it here, and from this I obtain h as 2g v squared over a squared. Then finally I also checked the physical dimensions of the left hand side and right hand side, and I saw that they match.